Okay, so welcome everyone. We'll be discussing the Starter 74 Div 4 question 3. Odd even binary string. Okay, so it is given that Chef had an array of length n, thus that the time the constraints are given that every element in AI is less than n for every index, and he has constructed another binary array b of length n. Okay, so b of length n in such a manner that if bi is equal to 1, then the frequency of I in A, okay, is odd. And if bi is equal to 0, the frequency of element I in A is even. Okay, so it says as usual, chef has forgotten the original array and now we have only the binary. Yeah, so we have to find out whether it is valid array or not. Okay, so the approach for this is pretty very much trivial. Like, you know, if our, let's say the size is even. Okay, so if the size is even, then we cannot have odd, and then another odd because odd equals 3 plus 3 equals 6. And what if we again add 3 or any odd number? It becomes 9, which is odd, but our size is even. So they won't go together. So that is an issue. So what we have to do here is just check, like we cannot have odd, and we cannot have a total of odd elements in an even size array, and the same way even elements in an odd size. So we know a binary operator XOR that returns us if there are even number of elements, it returns us 0, and if there are odd number of ones, even number of ones, we get 0, and if there are odd number of ones, we get 1. So by this we can find out whether we are getting a 0 or a 1. I just refer to the code. Yeah. Okay, so here what I'm doing is, for every element, I took out the XOR of every element. So if I consider this one, the first one, so the XOR of 0 and 1 will be 1, 1 and 0 will be again 1, and 1 and 1 will be 0. Okay, so if my XOR comes out to be 0, and I'm using here a binary operation, n and 1, any number in binary form, if it is even, it has to contain on the 2 power 0th index, because we know that every binary index starts from 2 power 0, 2 power 1, 2 power 2. So 2 power 0 has to be 0 for it to be even. So if it is even, then we are good. If it is odd, then we are in trouble. So no. Otherwise, the same vice versa condition, and we are good to go. We are doing this because you know pi is equal to 0 if frequency is even, and odd. So a ith element frequency is even. So if it is even and array size is also even, then they both must collide. Whatever you say, they both must be consistent with each other. So XOR tells us, gives us the addition basically of even odd will be even, odd will be even, same way. Okay, so moving on to the next. Okay, so Shiv gives an array A with n elements, and to Babla, and Babla's task is to find maximum non-negative integer x. Okay, so we have to find the maximum non-negative integer x. no element in the array belongs to the range minus x to x. Okay, so we have to find the maximum non-negative integer. Okay, so there are some observations that were so we are given a array with n elements, and we have to find the max non-negative number uh, x such that no element lies, yeah, in the range minus x. Yeah, this was the question. So if we have a1 and a2, an, so no element should lie in the range this one. Okay, so there was some pretty common observations that would need to be made. So the maximum non-negative element. Okay, so the maximum non-negative element will be, you know, uh, on small, uh, the smallest element sorted array. This was the very first observation that was to be, and second one was for every negative element we can reverse the sign and you know can find the smallest element and the one is element is out. Okay, so these are the basic observation, basic thing to be made. Let me just show you else. Okay, so let me take this one. 8, 4, 2, 5, and then 2. Okay. So if we just sort it 2, 2, 4, 5, and 8, we can obviously see here that if we take any element greater than 8, let's say 9, then all the elements will lie in the range minus 9 to 9. So this one gets cancelled. If we take, let's say, greater than 5, again, these elements will lie. If we take greater than 4, again, this element will lie. If we take 3, again, this will lie. So we can take something lower than this, and something lower than this that is greatest will be 1, I guess. Yeah. So 1 will be the best possible answer for this one. So it, you know, satisfies the first condition or the first observation can be proved with this example. The second one, let me just take, you know, 7, 9, minus 10, 8, 12, and 17. Okay, so if we just sort it, then minus 10 will come at the earliest, which will not be beneficial for our case because if we choose minus 10, okay, so let me just choose minus 10. So according to the question, no element should come in the range uh, minus 10 and minus of minus 10, so which will be like minus 10 to 10. But here, all, I mean, maximum element comes under this range. So what we can do is for every negative element, we can just multiply it by negative, and we can get a positive number, and then just sort it out. And again, like the first one, the minimum element minus 1 is our answer. Okay, so where will our case fail? So let us think like if we have a 0 in the elements, so there will be no element will be there will be no non-negative maximum number, because 0 is the greatest non-negative number, and after that minus 1. And if we choose 1, then from the range minus 1 to 1, we have a 0. So if we have 0 in our array, then it's a no. Let me just refer to the code once. Yeah, so it was pretty easy that first took the elements, uh, took the input, and then if any an element is less than 0, negative, made it positive, sorted it. If if the smallest element, like if we sort any group of positive integers, and if we find 0 at the first place, then it's a bad luck. There is no non-negative maximum number. Otherwise, the maximum number will be the smallest in the array, and minus 1. Yeah, and this will be the end of this question. And LCM hits GCD. Okay, so we were given here two numbers, A and B. We have to find the minimum value of AX, LCM of A comma X, and minus GCD of B comma X. Okay, so this was pretty tricky question. So there were some observations that needed to be made here. So let me just define the observation. GCD of any number, B comma X, will always be less than equal to minimum of B comma X, will be true. And if we take the LCM of B comma X, minimum of B comma X is, so we have to maximize these. So we have to take the minimum. No, we have to minimize this. So if we have to minimize this, we have to increase the GCD. Okay, so if we have some number LCM A and X, and then minus GCD of B and X, and if we have to minimize this, so minimizing any, what we can do is we can either decrease the LCM and increase the GCD, or we can put both 0, LCM is equal to GCD, and then it will be pretty much cakewalk. So got an intuition that let's say if we have 12 and 15, 12 and 15, so what will be the minimum number such that this condition suffices, like this condition produces the minimum value. So what I did was, if I take the GCD of both the elements, I will get, I guess, 3, which will the minimum element that will divide both of them. So if I take LCM with the first one and GCD with the second one, I'll get, I guess, 12 minus 3, which will be 5. Sorry, 9. So we just have to find the GCD of the given A and B, and that was our answer, and put it in the equation, and we would get the answer. So this was it. Thank you.